Good day to you. This is Anagalactic bringing your space-time geometry episode. Space-time is a most interesting concept. You will hear very often that space-time is curved. That is the general accepted way of expressing the geometry of space-time, is that space is curved and time is curved because they curve together. This is an artifact of linear algebra that it had to be expressed this way. There is no other way to express space and time together except in the same geometry, which is linear geometry, very often called Euclidean. Those are synonymous. Now, the actual nature of space-time is elusive. It is considered, and you can read between the eyes, so to speak, when you hear powerful professors attempting to convince you that this can be understood and that they do in fact understand it, and so they're going to teach you what they know about space-time so that you can understand it. You won't, because they don't. And the reason nobody understands space-time is because it's being expressed in Euclidean geometry, which simply cannot do the job, as I have proved. Today, we want to get the actual physics of space-time. It is a true construction in the sense that it has been proved by experimental research that in fact the conversions for general relativity and special relativity having to do with the geometry of space-time are sufficiently accurate for space travel, which means it's as accurate as is possible for the purposes of Earthling space travel. It works. It works for humans, and so it is miraculous. Space-time is a miraculous discovery. And the way Einstein did this is well worth the effort expended to find out how he came up with this formulation. We won't go into that today, although I have in the past in lectures which will never be watched again. All 550 of my lectures that I've produced over the past 3 years will never be watched. They were watched. One of them, my episode on the Dirac equation, has been watched 340 times last I looked, which is good for this tiny station, which has no accreditation, is not involved with Bitcoin or money or Patreon. I have no desire to further my career. My career has already been a total success. This is my second career, which is in science, and I've gone over what I used to do in the early part of my life. It had nothing to do with science. But now I've been shown in my life path, and I do express myself this way, I didn't have a blueprint. I wasn't born reading the instruction manual for how to get through life. Nobody has such a thing. And so I do express what occurred in my life beneficially to me, objectively, not as if I really accomplished anything, except in following guidance, which is mysterious. Now, in the case of space-time, we're not dealing with fanciful notions, humanistic notions. We're dealing with objective reality. And the way modern science evaluates success is tried and true, and there is no real reason to question the scientific method or the scientific process. if it lives up to its own expectations, which in the case of space-time absolutely is true. So what was the improvement? First of all, you have to know what the prior conception of space was before Einstein. This is actually a reformulation of space. Now, the notion of time being part of the equation, that is entirely new. Nobody had ever done that before. You could add Minkowski's name, who is actually the man who invented space-time. I have probed as far as I am willing to go into Minkowski's state of mind after he learned of Einstein's usage of Minkowski's geometry. And I see no conflict. It appears that Minkowski was absolutely comfortable with the fact that Einstein got all the credit for space-time. And there are valid reasons for that, but I should still have to say on Minkowski's behalf, he certainly was generous. If he didn't say, hey, Einstein, hey, it's not Einsteinian alone, it's Minkowski Einstein, if you want to give the old man credit here. He never did that. The mark of a true scientist, one of the signal characteristics of a true scientist, is absolute selflessness. He's no interested in self. So anybody who's doing science for money simply is not doing science. Now, in the realm of technology, which dominates the modern mind 99%, science is simply technology. It's not anything else. Well, that's ass backwards. And so I do go to the opposite extreme and impugn the entire technology industry. Not because I hate it, not because I don't understand it. I fully understand it to the same degree every scientist does. It's miraculous, but it's earth-based. And that's a new perception, one which physics has not really been able to accept, except in a totally mystical, irrational sense, which is understandable since scientists are humans and they've reached the end of their rope. Space-time is as far as science will ever get. Now, I've gone farther, and that's what we're going to talk about today, is the geometry of space. The geometry of space. There is only one so far, except for the one that I discovered in 2022. So the first thing that anybody listening, trying to figure out if I'm making sense or not, the first thing you need to understand is that there are now, as of now, 2024, there are two geometries. But for 2,300 years, as best we can estimate, there's only been one geometry. And prior to 2022, there has ever and always been exactly one geometry. So you need to be absolutely certain in your own mind, this is the result of my research. I'm sharing with you an understanding that you need. This has been proved, it's been validated. You do have to trust that I know what I'm talking about. I trust that you do. So, the true name of Euclidean geometry, you could say it's geometry, but I want to give you an analogy. The right term is not geometry. For this reason, you say that you're studying simians, apes. You're studying perhaps African apes. But someone says, or perhaps you yourself say, that you're studying animals. Animals. Well, animals is a much bigger class. And apes are simply a type of animal. So if you're studying apes, but not other animals, and it's asserted that you're studying animals, It's true, but it's superpositionally true. And it's inaccurate because you have the hierarchy wrong. You're not studying animals because you're not studying the class of animals. You're studying one type of animal. Now, in geometry, we are taught in school geometry. But if you care to check, if you're not certain what it was that you were taught or learned or that you know now about geometry, I can tell you, and I will be correct, but it's not the word geometry, because that's a class name, like animals. Whereas the geometry that we were taught is not comprehensive to the class of geometry. It's one specific geometry. And the reason that this is so incredibly confusing to all men, all physicists, all students, absolutely baffled in the use of the accepted terminology that we're studying geometry, because it's a fact that there are named geometries. All of them are misnamed because there's only one geometry, and it has a specific name which is accepted, and yet it has not changed the convention, which again is superimposed two separate definitions for the same thing. That's always a mistake. Always a mistake. I won't go into how I'm actually an expert in this area. That's called morphology. And it's a branch of morphology called classification. It's extremely important, but it's not very glamorous. But that is what I do. So the nature of what we call geometry is actually just one specific geometry, but since it's the only geometry, there is some nomenclatural confusion. So let me give you the correct term for what is called geometry. You could say it's geometry in the same way that you say that apes are animals. So trigonometry is geometry. Trigonometry. Trig comes from the Greek word for three, because of the three lines making a triangle, forming the basis of what we call mathematical geometry, not often by that particular name, but synonymous names. It's the geometry of the line which is extended to a linear system. When you have three lines, they're all in the plane, which is now 2D, two lines. A two-line grid is said to constitute the plane. It should be more specifically identified as such. It's not just the plane. It's a very specific plane. It's the linear plane. It's not circular or any other shape. It's two lines making a grid with a zero at the bullseye. That is how science has been run for over 2 millennia. Only trigonometry. So don't call it geometry. It is, but now there's a second geometry. This leads us into our formulation of space-time, because there is a split where before Einstein composed space-time, according to the Minkowski geometry, and it is a linear geometry, there was no perception of space. It simply is. In other words, space is axiomatic. It has no characteristics. But what happened in the 19th century, in the sudden confrontation with sphericity, the spherical universe, brand new, absolutely shockingly new, And science has not been able to adjust. It has not been able to adapt to the reality of the spherical universe. All of the top brains, the top physicists and mathematicians all say, implicitly or explicitly, because they have no choice, is the universe is a grid. And space-time, as Albert Einstein formulated it, is a grid. That does not work. It does work for Earth science, including space travel. That's one of the Earth sciences. We're able to get off the Earth, and if they're human beings, we usually can bring them back. Although it's inevitable that there will be disasters in outer space. Mostly NASA has been spared that. We haven't lost a man in space, although we lost a few men on the ground in a very stupid error that those jackasses never should have allowed to happen, where Grissom and White and I believe one other man, it's kind of slipped my mind, it was traumatic to all of us to lose those two magnificently trained astronauts in an oxygen fire in the cabin on the ground. But eventually men will die in space. The Russians have lost men in space. And the stories are rather heartbreaking. Just wait for the man's heart to stop beating as he circles the Earth unable to get home. Tragic. And Apollo 13 is an amazing movie. Tom Hanks, I believe, plays the role of the mission commander. And they very nearly lost their lives, but they got back. Now, all of this is to say is that linear algebra is responsible for these miracles. These miracles come from linear algebra alone. No other geometry has ever been used. Now, in the formulation of space-time by Albert Einstein, he extended the 3D system, which had been used exclusively up to that time, to describe volume space with a cubic grid, a cubed universe. I could make a comment on the nature of the cube and cubic equations, but it's very well known to mathematicians just how deep that goes. The cubic equation was a major nightmare for mathematicians who tried for centuries to figure out the cubic equation. It's never fully been figured out. But that is the nature of the geometry used, which, let me remind everybody, it is miraculous. What is so difficult, right to the present day, to grasp, to face, to just intuit directly, to absorb this brand new universe, which simply is not cubic. It's spherical. And what the problems that has produced do not affect technology at all. Technology can do anything that's related to Earth. Anything that's Earth-based has to do with the lives of men, the betterment of humanity, such as the harnessing of electricity. All of this is done with calculus. And in context, the definition of calculus is the tool that makes linear algebra work for technology. That's why the discovery of the calculus by Leibniz was so incredibly important. And then Newton, simultaneously with Leibniz, got the other definition of calculus. And there are two, and they have to be merged. And they never have. Not in any textbook. Because the physicists don't understand the calculus. They simply can't. They just know that it works. It's based on an Archimedean principle of balance, and it has to do with the quantum limit of measurement and it has to do with an extraordinarily elusive concept called the delta, which is the portion of irrational numbers which must be thrown out in order to achieve technological miracles. Miracles of technology all come from trigonometry. Trig. But when you're analyzing curved surfaces, which everything in the universe is curved, nothing in the universe is linear. Nothing at all in the universe is linear, with a footnote, which we won't get into right now, but it will come out in our future discussions. There is linearity in the universe, obviously, and it's miraculous for earth science. Where it fails is in attempting to understand reality. Reality cannot ever be understood with trigonometry. Trigonometry is synonymous with geometry in the old sense. It's the only geometry, is trigonometry. It's also linear algebra. That's trig. And what makes it work is calculus. Calculus. The sine-cosine system is strictly based on calculus. The complex number system is strictly based on calculus. What is calculus? It's basically, for Earth, it's miraculous, because it makes trigonometry useful. Why? Because it's the tool that rationalizes to the utmost possible degree curvature. Curvature. That's the meaning of calculus. It's the tool, and it's the only tool we have to get at curvature. And in all the textbooks, I've begun this sentence twice in previous lectures and never finished it, so this is kind of a regrouping moment here. The calculus is based on a lying, cheating, miserable, underhanded, illogical, irrational kludge. Learn the word. Kludge. It's pronounced kludge. And it's from computing. It means you take a piece of bubble gum because you can't make your shitty system work, and you shove the piece of bubble gum in to just make it kind of work until you can come back and actually fix your system. Calculus is that bubble gum. And it was so miraculous and so overpoweringly miraculous. The harnessing of steam and the harnessing of electricity, and then the incredible surge of technological wonders, was 100% due to calculus unlocking trigonometry. Trigonometry. So the first thing you have to know about Einsteinian spacetime is that it's trig. It's trig with calculus. It's trigonometry with calculus. It is not a new geometry at all. And that's its greatest accolade, but it's also its greatest failing. And it wasn't until the 20th century, after Einstein had formulated both special and general relativity. This would be after World War I, when both special and general relativity came into wide acceptance. In the 1920s, you know the story of the discovery of the universe. The universe was finally discovered through telescopy. Finally, long after the days of Galileo, who had one of the first useful telescopes. I think about 400 years later, a little less, the Great Mount Wilson Telescope, one of the greatest achievements of mankind and well worth the name one of the 7 wonders of the world, was the Mount Wilson Telescope. It had electricity, and it was the first telescope, I'll just say of that magnitude, that ran on electricity to guide it. The guidance system is critical, absolutely critical, and nothing could have been done with that telescope at all if it hadn't been for the discovery of photography. Photography. So electricity and photography and the size of the telescope, meaning the size of the mirror, were so astronomically difficult to achieve that it took the entire history of the race of mankind to get all 3. Photography, electricity, lens. The mirror is actually a lens. It's the incorrect term. It should be called a mirror. Too bad I'm calling it a lens, because it is. A mirror can be used as a lensing tool. So the universe was discovered in 1923. Instantly, the physicists realized from analyzing light spectra, it wasn't just photography, it was also spectroscopy. The analysis of the light band, spectroscopy, that it gave the clue for the Big Bang. It also involved Einstein at cutting-edge physics in a practical sense, because mankind now had the task, for the very first time in history, to try to understand the universe, which had just been discovered. It's only been a century since the universe was discovered. We did not know there was a universe. You could argue with that. I will defeat you in any argument. We discovered the universe. That's incredibly important to understand, because that was simultaneous with the discovery of space-time, and they've been bound together ever since. Rightly so is not for a scientist to say. If you say yes, then you're done. If you say no, then everybody's looking at you. Well, what's your answer, wise guy? I have the answer. Space-time, first of all, is trigonometry. It's trig. It's straight lines. That's all it is. So how did Einstein get a curvature? And why did he need to get a curvature? Because gravity is a spherical phenomenon. That is not... Everyone knows that. But it's so odd that everyone knows it, and yet none of our physicists have put these two facts together. That gravity is a spheric phenomenon, has no linearity in it at all. It's a spherical phenomenon. But our so-called geometry is linear. Linear. Which means that doesn't work. And nobody has been able to realize that. I consider that to be one of the most magnificent ironies. I-R-O-N-Y is pronounced irony. Irony is the study of metals, okay? Irony has to do with iron. But irony is quite an ironical term in itself, isn't it? It certainly is. But this takes the cake, and it's produced psychosis, mass psychosis. Endemic, pervasive, ubiquitous psychosis that has gotten so out of control that the psychosis itself is assumed to be the definition of reality. Now that all the physicists have lost their minds, technically true, they've lost their minds, well, that redefines reality then. That's the situation that I walked into, and I solved it. So we're going to understand space-time in a new way, because Einstein got it right. He got the linear solution. And you know the story, the geometric construction that he made in his mind, and then the way he manipulated mathematics so that it would work, is the story of what is called non-Euclidean geometry. That's part of the psychosis. No, it's not non-Euclidean, it's actually Euclidean. It's 2,500-year-old geometry being applied to the universe for the first time. And it's inaccurate. Of course it's inaccurate. You can't use lines to compute the universe. It can't be done. The Big Bang proves that. The Big Bang proves one thing. Your linear number system is shit. You want to understand the universe? You're going to need spherical geometry. Well, that's what I discovered, because nobody else could. So how does this actually address space-time to make it understandable? To understand that, we're going to keep this brief. We'll cut this off at 40 minutes because I don't want to tax your poor brain. Space has no characteristics. It never has. What Einstein said was, yes, it does have a characteristic. Space is curved. That is correct. We finally discovered that space has a characteristic. It can curve. It does curve. Now, there's a big footnote there. So we're just going to accept that for now. That space curves. That's actually not true. But we're going to assume that Einstein was right. Because it's true enough. And it's the only way to say it to make it understandable in linear logic. So all of this is consistent, but there's a gigantic, gaping, bleeding wound at the heart of the Einsteinian system. Now, space and time, it can now be said that they are geometrically related, and they are. Otherwise it wouldn't work. Because space travel involves geometry. That's how you change course and make course adjustments. You have to change direction. That's geometry, not mathematics. But you can't transmit geometric information to your spacecraft, or use geometric information to control your spacecraft. Geometry occurs in here. What you do is you use mathematics to translate it to the machine language. That's what mathematics is for. Mathematics is to translate geometry to action. So, where does that leave our definition of space? We now have a new definition of space. This takes the place of the old idea of ether, which is a red herring. It's not that ether does or doesn't exist. You could say it either way. The question is, what is ether? And it's the same question as asking, what is space? So to say that space is ether does nothing. You're just changing the word. Ether is synonymous with space. So is space a substance? It has to be. But this depends on a alternative definition of substance, and there's no correct word for this, because this is axiomatic. Space is space, that's all you can say. Well, not true. You have to say something about it in order to use its characteristics. So space is there because it's emptiness, and that is space. But it has one outrageous characteristic. It's the medium of light. It's the medium of light. So you have to ask then, what is light? So far, nobody knows. We, of course, have definitions for light, and we even have mathematical formulations that treat light reasonably accurately, or we wouldn't have lasers, for instance. So we do have a worldly, earthly definition of light. What we do not have is a universal definition of light. We now need to understand light, not in terms of man's progress on Earth. We need to understand light in terms of the universe which was just discovered. So, what is the role of light in the universe? We can begin by saying that light travels through space. That is how we say it, and there's a footnote to that. How does it travel through space? Well, right off the bat you can say it travels invisibly. Invisibly? Well, a moment's thought should convince you that does make sense, but it's kind of spooky. Space is invisible, and as light travels through it, it's also invisible. Invisible. It can't be seen. The only time light can be seen is when it transitions from its propagation through space back into an atomic system. And it's that simple. It's really that straightforward. So get a grip on that. This gets so deep so fast because it's brand new and nobody has the tools to even talk about it. I do. So light travels through space. That means that the definition of space and the definition of light are bound together. Now, how do we know that light is traveling through space? It's because it has motion. Motion is not space. Obviously not. But there's a direct relationship between them. You can only have motion in space. But how do you know that it's motion in space? Time. Time. So light takes time to travel. It takes space to get through, and it takes time to travel. So space and time are related exactly this way. Light speed. Light speed. Speed is the key term. It's the speed of light. Well, what is speed? Technically, speed is different from velocity. And it's so simple, but it's so rarely stated. What's the difference between saying something's speed and something's velocity? It's that speed is a simpler concept, having nothing to do with direction. Of course it does, but if you don't specify the direction, then it's just its speed in some direction unspecified. But if you specify the direction, then it's velocity. Velocity. The velocity of light. What is the direction that light goes in? Since it does have a velocity, what is its direction? It was shown by Christian Huygens, who lived around, well, you can find out more about Christian Huygens, who is one of the founders of optics. Along with Newton, Huygens is considered the co-founder of the science of optics. Of course, there had been science of optics before that, but Huygens made a magnificent discovery, which Newton actually did not understand. And in fact, Newton explicitly disagreed with Huygens, not by name, but by theory. It's called a theory of light. And Newton said that it was corpuscles. And eventually Einstein would prove that Newton at least had a good point. But Huygens had a completely different theory of light based on waves, wave mechanics. And his statement was, and it has been proved that he was correct, that light as a wave propagates spherically. So light is a spheric phenomenon. Just as gravity is a spherical phenomenon, light is a spherical phenomenon. And this is where Einstein failed. He never understood that. He was a Newtonian. He believed in Newtonian mechanics. And so he considered light to be particles. He's half right. Or you could, actually the right way to say that is, he's superpositionally right in the inferior position. He's superficially right. You can say that, and in linear thinking you have to, because everything is a point in linear algebra. And so since everything is points, the smallest things have to be particles. And that's the basis of the standard model of particle physics. It's Newtonian. It's not Huygean. It's not based on wave mechanics. It's not based on sphericity at all, because science has never been able to handle sphericity. It doesn't know about sphericity, except through a cubic or hypercubic grid, which is no longer adequate because it's not real. You're putting something over the universe to interpret it for your ground-based, worldly, death-oriented mind. We now need the living definition of light, what it actually is. Not in terms of human stupidity and death. Not in terms of the miracles that amaze us on Earth. That's so limited that I'm not even going to talk about it because it's too deep for most people to handle. Because it changes your whole perception of reality. Well, that's the whole idea now. That's exactly what the universe is calling us to do, is to reinterpret reality correctly instead of being blind and stupid. It's to get it right so that you're happy. I hope this makes you happy, but we're coming up on 45 minutes now. Don't forget, this took 3,000 years to figure out, and I'm the only person who knows this. So have a little compassion, have a little sympathy, but most importantly, have a little patience. I'm a beginner, attempting to do the most difficult feat ever undertaken by any scientist in the history of mankind. I'm going to give you the universe's final lesson to humanity, to a threshold. A brand new threshold of reality is breaking right now in the summer of 2024. This is going to go worldwide, or I will die trying. I'm the right man for this job. So what is space-time? First of all, there are two different data types. That's not known in physics, so you're going to have to accept that. One of the data types is called time, but it's incorrectly called that. So space-time is a misnomer. And there is no such thing as space-time, except in Bronze Age science. Bronze Age science, the age of the Greeks, the age of trigonometry. We're well past the age of trigonometry now. But our mathematics has not caught up. We have no one who knows anything about geometry, and our geniuses are all occupied elsewhere with money. So there's no one left, except some man from the wilderness, that would be I, to explain that it's not time-space. But the first thing you have to understand is that space-time is a two-component number. Light speed is a two-component number with two different data types. What Einstein did was he fused two things that don't have any relationship that's obvious. And the way he did that, first of all, by observing that space is linearized in 3D, he added a fourth line. And he said that that's time. Now what I've proved is that the three-line 3D system for conceptualizing space, first of all, is not spherical, obviously. It's linear. But it's a data type. And the data type is quite simple. It's the metric of the space, which is linear spatial separation, which I very often abbreviate LSS. Linear spatial separation is the basis of all science, and it's the only measurement we can make. It has to be linearized, which means linear spatial separation from zero. So what that actually is, according to my discovery in 2022, the 3D system for space is a derived system. It's the calculus derivative of spherical space. Let me say that again, because this is the turning point. The present Euclidean linear representation of space, both in 3D and in 4D, is the derivative. That's derivative space with respect to spherical space. So the whole system is already derivative. Now what Einstein did was he got another derivative number, and time in the Einsteinian formulation is a derivative number. Time is derivative. It's not real. Nothing that's derivative is real. And linear spatial separation between us with our telescope and a star, that linear spatial separation is derivative. That's not the actual separation. The actual separation is in what is called space-time. It's not spatial. It can't be spatial. But if you say that it's spatial only, that's derivative. You could also say that it's temporal. There's a temporal separation of time. That's where a lot of the madness comes from in modern speculation. It's wildly entertaining. Has a lot to do with space-time travel and conundrums, but it's all due to misperception because we're seeing linearly. We need to graduate now and see spherically. And when you do see spherically, you see the actual relationship between one data type, which is space, and the other data type. Is the other data type time? If you're using the derivatives, yes. But if you're not using the derivatives, then space is not linear. It's radial. So space has a spheric characteristic, which is totally unknown to science right now, except I know it. So when you say space that way, it's different from Einsteinian space. It's different from Newtonian space. And it's most closely related to Huygean space, because light propagates spherically through space. Well, that means that space is spherical. That is a tautology. That requires no proof. So Einstein was wrong. But it's very, very difficult to see that. And here's how you can see it, and that we're going to close this off at 50 minutes. Because space is spherical, you can consider it either as a radial line, which is a spherical concept of the line, or you can consider it as the surface, which is a sphere. So the radial line makes a sphere, and the sphere is the result of a radial line. So that's the relationship between the two lines in spherical space. One of those, that is the sphere that goes out, you can think of that as space. So space is spherical from the center, But if you say it that way, and there is another way to say it, then time is on the surface of the sphere. The sphere is generated from the radial line, which is a force, the centrifugal force. And that creates a spheric surface called light. But it comes from a radial line. But that sphere is real, and it has a surface. And on the surface of the sphere, you would say that that's where time is. That's true. But the sphere is not time. The sphere is energy. And time is one of the two derivatives of energy. It's measured as frequency. And you know what the reciprocal is in that formulation? What's the reciprocal of frequency? Frequency is a temporal term, it's not spatial. It's the number of clicks on a closed line. Click, 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 click. It's the number of those. And that's frequency. Well, the reciprocal is wavelength. That's a spatial term. That wavelength is not spatial. That's what's missing. Is that the wavelength is not spatial. We continue to measure it as if it were spatial. But that's the error that leads to the quantum paradox and the misperception of space-time. So in the next lecture, I'm going to give you the full atom-braided solution with all the proof. And this is going to tax you, it could kill you because you're so stupid. So step up your game. Take some vitamins and wipe all the emotion off of your face, because you're going to get it straight from the top, from me, the actual meaning of space-time. I hope I've given you a solid foundation for what is to come. Don't forget at any time that this is by far the most difficult problem that's ever faced humanity. And a lot rides on the answer, which is why I get quite emotional and I need to control my voice. Okay. So in the next lecture, I will have a shower and I will have shaved. And my eyes will probably have recovered by then from my morning allergy attacks. Ooh. So I hope you're having fun. This is the most fun a human being can have. You're about to get the secret of the universe that'll put you ahead of the physicists. And most importantly, you'll be immune to their lies. And you'll be able to turn back to your creator and understand his design. If you don't, you lose. I'm going to make sure you're a winner. Stay tuned. We'll be right back.